Ever wondered why shadow stretches and shrinks with the sun? Why does it disappear at noon but creeps long at sunset? A shadow isn't just a black patch on the ground. It's a 3D volume where light is blocked. Even the edge of a shadow isn't simple. It's fuzzy, not sharp. When an opaque object blocks that light, a shadow forms. If the light source is small, the shadow is sharp. If the light is large or spread out, edges blur. A shadow is the dark area where light is prevented from reaching a surface. It has two main zones, the umbra, full shadow, and penumbra, partial shadow. Sometimes there's even a third zone, the antumbra, where the object appears smaller than the light source. Shadow size depends on both distance and the angle of light. Move the object closer to the light. The shadow grows larger and softer. Move it away. It sharpens and shrinks. Also, the surface receiving the shadow matters, flat or curved. Earth's shadow creates lunar eclipses. The moon's shadow causes solar eclipses. The experience depends on which shadow zone you're in. In the umbra, total eclipse, penumbra, partial, antumbra, annular. Surprisingly, if you sweep your hand past a spotlight and the wall is far away, the tip of the shadow can move faster than light. But it doesn't violate physics. No mass or information is traveling at that speed. Eratosthenes used shadows to estimate the Earth's size in ancient Egypt. He placed sticks in Syene and Alexandria and compared their shadows at noon. The result? A remarkably accurate circumference calculation over 2,000 years ago. Today, you can estimate a building's height with just a ruler and the sun. Use similar triangles. Measure the shadow length of a smaller object and compare it to the building's shadow. This principle is used in surveying and architecture too. Architects use shadow analysis to design energy-efficient buildings. By studying where shadows fall throughout the year, they optimize light and reduce overheating. Urban planners also use trees to create cooler microclimates. In space, shadows tell big stories. The transit method detects exoplanets by measuring the tiny dip in a star's brightness when a planet crosses in front. Even black holes cast shadows, a dark zone where light can't escape, surrounded by a photon ring from bent light. In psychology, Carl Jung called the shadow the part of ourselves we hide or deny. It contains instincts, impulses, and even creativity. Facing it doesn't make us darker, it makes us whole. Throughout history, shadows have symbolized mystery, fear, and the unknown. From shadow puppets in Asia to Plato's cave, they challenge our perception of reality. In film noir, a long shadow signals danger. In art, it creates drama. Shadows are more than darkness. They're windows into geometry, astronomy, psychology, and design. They help us understand the world and ourselves. Next time you see your shadow, don't just step over it. Look closer. Want more science behind everyday wonders?